In 1989, as the Cold War was drawing to a quiet close, Boeing rolled the most audacious commercial gamble in aviation history out of a factory in Everett, Washington. The 777 program represented a multi-billion-dollar bet on a wide-body aircraft designed entirely by computer, the first jetliner ever developed without a single physical mock-up. Engineers called it the paperless airplane because every rivet, every wire bundle, every hydraulic line existed only as digital code before metal was cut. At the time, it pushed Boeing to its absolute maximum limits. The development consumed 7 years. The testing regime demanded over several thousand flight hours. One certification failure could have destroyed an aircraft family before it ever carried a paying passenger. The gamble paid off. The 777 became the most successful wide-body commercial aircraft in history. For 3 decades since, the aerospace industry has accepted a foundational truth. Boeing and Airbus split the world between them. 2 companies, 2 philosophies, 1 duopoly, geography, regulation, and the sheer capital intensity of building commercial aircraft guaranteed that nobody else could realistically enter the market. The duopoly seemed permanent. In 2025, Boeing's new CEO, Kelly Ortberg, confirmed what industry insiders had suspected for months. Boeing has initiated preliminary design work on a clean-sheet narrowbody aircraft to replace the 737 MAX. Former CEO Dave Calhoun estimated the cost at approximately $50 billion. How accurate are these estimates? Who knows, but here's what makes no sense. Boeing currently carried $54.1 billion in consolidated debt as of the end of 2025. Its free cash flow in 2025 was negative $1.87 billion. It just cut 17,000 jobs. It is still absorbing the $8.3 billion acquisition of Spirit AeroSystems, which includes its debt. Billions of dollars to develop a new aircraft won't materialize from current cash reserves. It won't come from existing free cash flow. It won't come from a single capital raise without devastating shareholder dilution. Yet, every airline in the world is watching Boeing's next move. Because if Boeing doesn't build this aircraft, the entire competitive architecture of commercial aviation collapses into a monopoly. So, how can a company with more than $54 billion in debt afford to spend billions of dollars on a single airplane? To understand why Boeing is contemplating a bet to build a new aircraft, we need to understand why the 737 can no longer be stretched, patched, or re-engined one more time. The original Boeing 737 first flew in 1967. Its fuselage cross-section, wing-mounted position, and landing gear height were designed for the engines of the 1960s. Over 5 decades, Boeing iterated on this basic architecture through the 737 Classic, the next generation, and finally, the MAX. Each generation bolted newer, larger, more fuel-efficient engines onto essentially the same airframe. The physics worked until they didn't. When Boeing needed to fit the CFM LEAP engine onto the MAX in the 2010s, the 1960s era landing gear was too short. The engine nacelles wouldn't clear the ground. Engineers mounted the engines further forward and higher on the wing, fundamentally altering the aircraft's aerodynamic behavior. The nose wanted to pitch up under certain flight conditions. To compensate, Boeing installed software called the Maneuvering Characteristics Augmentation System, MCAS. The flawed implementation of MCAS led directly to 2 fatal crashes: Lion Air Flight 610 in October 2018, Ethiopian Airlines Flight 302 in March 2019. 346 people died. The 737 MAX was grounded worldwide for more than a year. Boeing's long-term debt exploded from $13.8 billion in 2018 to over $54.1 billion by the end of 2025, compounded by the COVID-19 pandemic. Then, in January 2024, a door plug blew out mid-flight on an Alaska Airlines 737 MAX 9, exposing systemic manufacturing quality failures. The FAA imposed unprecedented production caps. Boeing's cash flow was severely limited. The message from physics, regulators, and the traveling public was identical. The 737 architecture is exhausted. There is no alternative in Boeing's lineup. There is no re-engining option that doesn't trigger a complete ground-up recertification. The airframe that generated hundreds of billions in revenue across 6 decades has reached its terminal derivative. Boeing needs something entirely new, and entirely new costs a lot of money. The cruelest dimension of Boeing's current predicament is that the company nearly built this airplane 15 years ago. In the 2000s, Boeing began serious conceptual work on a clean sheet 737 replacement. The design would have featured a wider fuselage, composite materials borrowed from the 787 Dreamliner program, and next-generation engines purpose-built for a modern wing. Estimates for the development costs ranged in the low to mid-teens of billions of dollars. Then, Airbus launched the A320neo in December 2010. The A320neo was not a clean sheet design, it was a derivative. Airbus simply hung new engines onto the existing A320 airframe. Development cost around the low single-digit billion-dollar range. Time to market 5 years. Fuel savings compared to older generation aircraft 15 to 20%. The airlines loved it. American Airlines, historically one of Boeing's most loyal customers, placed a massive order for both Airbus and Boeing single-aisle aircraft in July 2011. A320ceo, A320neo, 737 Next Generation, and orders for what the airline called at the time the expected new evolution of the 737NG, with a new engine that would offer even more significant fuel efficiency gains over today's models. American Airlines made the decision for Boeing on what to do with its aircraft lineup. This decision saved Boeing's market share in the short term. It also set in motion the chain of engineering compromises that would kill 346 people, cost the company tens of billions of dollars, and leave it facing a massive bill to build the airplane it should have built in the 2010s. The derivative that was supposed to cost $3 billion has, through crashes, groundings, production halts, lawsuits, compensation payments, and reputational destruction, consumed well over tens of billions of dollars already. The clean sheet design that was abandoned now costs much more because materials are more expensive, and certification standards are exponentially more stringent post-MCAS. Boeing saved several billions in 2011. It will now have to spend billions of dollars to develop a new single-aisle jet. Boeing's entire market capitalization in mid-2026 stands at approximately $175 billion. The estimated development cost of the new narrowbody could be anywhere between 10% and 20%, perhaps even more, of the company's total market value. Boeing's annual research and development expenditure across all divisions reached $3.6 billion in 2025. Boeing's full-year 2025 revenue was $89.5 billion. The company holds $29.4 billion in cash and marketable securities. Even liquidating every dollar of available cash would not potentially cover the bill to develop a new aircraft. For comparison, Airbus developed the A330neo, a wide-body derivative, for approximately $2 billion. The entire 787 Dreamliner program, Boeing's last clean-sheet aircraft launched in 2004, ultimately ballooned to roughly $50 billion in total costs. Though much of that reflected delays, supply chain disasters, and customer compensation, rather than pure engineering. Former CEO Dave Calhoun framed the stakes explicitly before his departure. He said the next leader would develop and call out the next airplane for the Boeing company, that it would be a $50 billion investment, and that it would all happen on the next leader's watch. That next leader is Kelly Ortberg, and the investment he must somehow fund equals the company's entire accumulated debt. The $50 billion estimate, according to industry analysts, includes several layers. First, the pure aircraft development, aerodynamic design, composite structures, flight testing, and certification. Second, engine co-development with partners like GE, CFM, Pratt & Whitney, or potentially Rolls-Royce, since Ortberg has reportedly met with Rolls-Royce officials to discuss architectures. Third, entirely new automated assembly lines to replace aging Renton facilities. Fourth, massive risk buffers for inevitable delays, overruns, and regulatory complications in the post-MCAS certification environment. Each layer is individually enormous. Together, they constitute the largest single industrial investment in American manufacturing history. However, who really knows how accurate that estimate is? Perhaps it is way off, but the price tag stuck. The significance of Boeing's next single-aisle gamble isn't really about money, and it isn't really about a single airplane. It's about what happens to human capital when a corporation stops building the future. Consider the mathematics of engineering attrition. In November 2024, Boeing issued layoff notices to 438 members of the Society of Professional Engineering Employees in Aerospace, SPEEA, Union. 218 professional engineers, 220 technical staff. In December, another 222 received notices. These weren't assembly line workers. These were the people who design aircraft. The total workforce reduction reached 17,000 across the company in 2024, roughly 10% of Boeing's global headcount. And this came after a 33,000 worker machinist strike in late 2024 that cost Boeing approximately $1 billion per month in lost production. The paradox is devastating. Boeing needs to execute the most complex engineering program in commercial aviation history. Simultaneously, it is firing the engineers required to execute it. The institutional knowledge required to manage clean sheet development, the tribal wisdom passed from one generation of engineers to the next, is evaporating. Engineers are simple. Put them in a room with Coca-Cola, donuts, pizza, and a cool problem, and they'll never leave. But ask them to spend their careers fixing production defects on a 60-year-old design, they leave for startups. They leave for Airbus. Boeing isn't just losing bodies, it's losing the capability to spend cash effectively. Every engineer who walks out of the door takes irreplaceable knowledge about certification process, supplier management, systems integration, and failure mode analysis. The money becomes meaningless without the minds to deploy it. This is the dimension that financial analysts consistently miss. Boeing's crisis isn't a balance sheet problem dressed up as an engineering problem. It's an engineering problem that no balance sheet can solve unless the talent pipeline is rebuilt first. While Boeing hemorrhages talent and debates timing, Airbus is not waiting. Airbus CEO Guillaume Faury has publicly confirmed the company is fully focused on launching a successor to the A320neo family by the end of this decade, targeting entry into service in the second half of the 2030s. Faury stated the target is 20 to 25% better fuel efficiency, with roughly half coming from next-generation propulsion. Airbus is simultaneously pursuing two parallel programs. The next-generation single-aisle, NGSA, represents a conventional clean-sheet successor featuring open-fan engines, ultra-slender wings, and a full compatibility with sustainable aviation fuels. The Zero E initiative explores hydrogen-powered aircraft using either liquid hydrogen combustion or fuel cells, targeting an ambitious 2035 entry into service. The financial asymmetry is staggering. Airbus sits on billions in cash reserves. Its narrow-body backlog exceeded 8,754 aircraft by the end of 2025, compared to Boeing's over 6,100. Airbus's A321neo has captured the middle of the market segment entirely, replacing aging Boeing 757s on routes where Boeing has nothing to offer. Airbus cannot wait for Boeing to launch. Boeing is probably crippled financially, but the clock is ticking in terms of net zero mandates and airline fleet renewal cycles. There's a cruel irony embedded in the duopoly dynamics. Airbus and Boeing are actually sold out into the 2030s. Airlines cannot instantly abandon Boeing for Airbus, or vice versa, even if they wanted to, because delivery slots don't exist. This gives Boeing a temporary, artificial grace period, but that grace period has an expiration date. If Airbus launches an NGSA by 2035 and Boeing has nothing to counter it, airlines planning their 2040 fleet renewals will have exactly one option. The fundamental question confronting Kelly Ortberg is not whether to build the airplane, it's how to finance it without destroying the company in the process. Boeing's CFO has guided toward a long-term target of $10 billion in annual free cash flow. If the company achieves that target, which most analysts consider optimistic, it would take years of directing every dollar of free cash flow toward the new narrowbody to fund the program. That is obviously impossible. The money will have to come from multiple sources spread over a decade. Internal cash generation covers a portion. Capital market raises, whether equity or debt, cover another portion, though Boeing already raised $24.3 billion through stock sales in 2024 alone. Government support, likely through defense contracts that subsidize aerospace R&D capability, covers yet another portion, though WTO subsidy disputes between Boeing and Airbus have historically made this politically explosive. Risk-sharing partnerships with suppliers and engine manufacturers absorb some development cost, though the 787 program demonstrated how badly outsourced development can go wrong. Boeing's acquisition of Spirit AeroSystems for $8.3 billion, including debt, was explicitly designed to re-internalize critical manufacturing capability that had been spun off and subsequently mismanaged. The technological risks compound the financial ones. Concepts under consideration include the transonic truss-braced wing being tested with NASA and open fan engine architectures that expose turbine blades to achieve massive fuel efficiency gains. Open fans present enormous challenges around cabin noise, vibration, bird strike vulnerability, and maintenance at cruising speeds. If Boeing commits cash to the wrong propulsion pathway, the consequences are existential. Yet, the cost of not building the airplane is equally clear. Boeing's commercial backlog at the end of 2025 stood at over 6,100 aircraft, valued at $567 billion. Customers' orders represent Boeing's lifeline, but they depend entirely on airline confidence that Boeing will remain a viable long-term supplier. If Boeing signals to the market that it has no clean sheet narrowbody in development, airlines planning their 2035 to 2050 fleet renewals will default to Airbus. The backlog erodes, revenue shrinks, the debt becomes unserviceable. The 737 MAX backlog alone exceeded 4,300 aircraft at the end of March 2026. Every one of those orders represents an airline that chose Boeing over Airbus. Every one of those airlines is watching to see what comes next. A Boeing with no next-generation narrowbody is a Boeing that loses its relevance in the segment that generates the majority of commercial aviation's total movements worldwide. Boeing still dominates wide-body operations, but wide-bodies don't move the masses, narrowbodies do. And in narrowbodies, Boeing is losing. In 1989, Boeing bet $5 billion on the 777 because there was no alternative. The wide-body market demanded a twin-engine aircraft that could replace aging trijets. Boeing had the engineering talent, the financial strength, and the institutional confidence to execute. The gamble was enormous, but rational. 37 years later, Boeing faces its successor gamble from the opposite position. Not from strength, but from debt. Not from institutional confidence, but from regulatory probation. Not with a surplus of engineering talent, but with a workforce hollowed by layoffs and a brain drain to competitors. The arithmetic seems impossible. Negative free cash flow against a decade-long development timeline. A depleted engineering workforce against the most complex certification environment in aviation history. But the arithmetic of inaction is worse. Surrender the narrowbody market to Airbus? Watch airlines migrate to the only manufacturer offering a next-generation single-aisle aircraft? become a wide-body and defense company, competing against Lockheed Martin and Northrop Grumman on one side and Airbus on the other, without the commercial narrowbody revenue that has historically funded everything else? When Kelly Ortberg makes the final launch decision, likely before the end of this decade, he won't be choosing between risk and safety. He'll be choosing between two different kinds of catastrophe: dollars the company doesn't have, spent on an airplane that won't fly for a decade, or $0 spent on a future that doesn't include Boeing as a relevant commercial aircraft manufacturer. Dave Calhoun was right about one thing: this will not just be an investment. What he didn't say is that it's also a test of whether the company, drowning in debt, stripped of its best engineers, and shadowed by the memory of 346 lives lost, can still summon the institutional will to build something genuinely new. The question isn't whether Boeing can afford to develop a new single-aisle jet, it's whether the rest of the industry is really paying attention to what happens if it can't. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?